Okay, so again, we're going to discuss the week one for the current trends and issues of information system. So week one is about Internet of Things, the introduction. Okay, as shown on the screen. So let's talk about the benefits of an IoT or Internet of Things. So the first benefit here is the big data. Second, we also have the improved efficiency. We have optimized performance. We have energy conservation, reduced costs, and real-time tracking. So again, these are the summarized benefits of the IoT. Okay, so there are some key considerations from 1990s up to future. So actually, Internet of Things is not new. Okay, so every day in our lives, so items have been controlled over the internet since early 1990s. Okay, so the paradigm shift how people and institutions interact with the internet in their personal, social, and economic lives is changing. Okay, so actually, as I remember from 1990s, before we have the actual Gmail account, we started with the Yahoo actually. Okay, and then we're using also the internet for what? We can use it for the chatting. Okay, for searching, researching, okay? So that's the purpose of the internet, okay? So passive engagement. For the passive engagement 2010, so many connected devices are designed to operate in the background with minimal human intervention, okay? So aside from that, the future, so policy areas might benefit from a review. So when you say IoT devices, will likely touch most aspects of our lives. Okay? So mostly we're going to apply the IoT every day in our living. Okay? So challenges of the IoT. What are the different challenges encountered by the IoT? So first is security. So how are you going to ensure that applying IoT or using IoT will ensure the robust and lifelong security in IoT products and services? Okay, so this is the first challenge that the IoT encountered. Also, we also have the interoperability and standards. Okay, so the voluntary use of open, interoperable, and widely available standards as technical building blocks for IoT devices will deliver greater benefits. Okay, so we're talking about the operational of the IoT and also the standards of the IoT. So next, okay, we also have the privacy. So this is a major challenge for an IoT. Why? Because mostly, if you're using IoT, you're talking about publicity or public. Okay, so we're going to promote transparency, fairness, and user choice in data collection and handling. So since most of the data are already available in the internet, there are times that the privacy is the main issue. Okay? Next, regulatory, legal, and rights issues. So the rapid rate of change in IoT technology could outpace the ability of associated policy, legal, and regulatory structures to adapt. So when we're using internet actually, there are some what you call the legal and right issues. There are times that some of the users are not aware of the legals and right issues. There are times that they are doing what? There are times that we're doing copy paste, especially if we're doing our research. We are unaware that we are doing plagiarism, okay? There are times that there are some people, okay, I'm not saying all, There are times that you're using an image that is not allowed if you're not going to put some references or acknowledgement. Next, emerging economy and development issues. Okay? So in order for the benefits of the IoT to be truly global, the unique needs and challenges of implementation in less developed regions will need to be addressed. Okay, so since we are growing, we are fast growing, especially we're using internet now. So we have to be aware. Okay, we have to be aware because not not all can access actually IoT. Okay, not all can reach internet. Not all can able to provide computers and network. Okay, there are some remote places. So these are the challenges again of the IoT. So we have security, interoperability and standards, privacy, regulatory, legal and rights issues, emerging economy and development issues. So there are guiding principles, okay, for the IoT. So first, promote internet and data infrastructure growth. So the government should promote the expansion of both wireless and wireline infrastructure and remove barriers to data center development. So we have to support, okay, we have to support internet, we have to support data infrastructure growth. It cannot only be supported by a one company. It should be supported by the local government as well. Next, encourage IPv6 deployment. Okay, so government should make IPv6 adoption a national priority as the IoT will drive up the number of connected devices. So as you all know, class, there are two types of IP. We have the IPv4 and we have the IPv6. Now, if most of us or all of us were going to use IoT or we're going to connect to internet, then IPv4 is too limited to use. So it would be much better if we're going to use the IPv6. So that's what the encourage IPv6 deployment is all about. Okay. Next, we also have encourage open voluntary IoT standards. So you should encourage, or we should encourage interested stakeholders to work together on the development of open, consensus-based standards that supports interoperability. Next, we have to adopt a collaborative multi-stakeholder approach to IoT policy discussions. Okay? So meaning to say, draw on the expertise of a wide range of stakeholders to develop appropriate solutions. So we need support also from the stakeholders. Okay? How to apply the IoT, what is the policy on applying IoT. Next, encourage a collaborative approach to IoT security. So it empower players to address security issues close to where they occur. Don't centralize IoT security. Okay? It might not be enough to secure your IoT if there's only one company that will secure it. Meaning to say, there is some national issue here, national security issue to be exact. Okay? That you have to collaborate with them to improvise the security in applying the Internet of Things. Okay? Next. Okay. Class, if the meeting ends, kindly join again, okay? Thank you. Okay, next, encourage responsible design practices for IoT services. So security by design, privacy by design, practices for IoT devices should be encouraged. So if you're going to design an IoT, make sure that your design is secured and you're considering also the privacy. So these are the guiding principles of IoT. So class, our learning objectives for today, so it's just an introduction, is 1, to define the IoT, 2, to know the benefits of IoT, 3, to know the origin of IoT, 4, to understand the sensors and actuators, 5, to know the difference between IPv4 versus IPv6, and then 6, to define wireless technology. So what is the Internet of Things? What is IoT? When you say Internet, it means interconnected computer networks globally. When you say things, that is the smart objects or the physical objects that can connect to the Internet. So what is IoT? So again, IoT is a computing concept where everyday objects can connect to the Internet. So it's not just the computers. We have the cars, we have the buildings, we have the household appliances. So we're talking about like what? We're talking about smart devices. We're talking about the, maybe if you want to remote the car, that's possible. Security of your house, that's possible, okay? Automating the gas, okay, the gas range, you can do that also. What else? Smartwatch, cell phones, okay? So what is the origin of the IoT? So the term IoT was coined by Kevin Ashton in 1999. So meaning to say the IoT term was started in 1999. So in 2002, Forbes published an article also entitled The Internet of Things, which quoted Kevin Ashton. We need an internet for things, a standardized way for computers to understand the real world. So now, for the IoT, okay, there are 4 waves of industrial revolution. On 1784, Industry 1.0, so this is the first wave. So they developed mechanization, steam, and water power. On 1870, which is Industry 2.0, this is a mass production and electricity. So this is where the electricity was developed. Next, 1969, Industry 3.0. This is where electronics, IT system, and automation was built. Okay? And then the next one, which is today, which is the present, Industry 4.0. So cyber physical system. I'm sorry about the spelling. That's physical. So PHY. And then Internet of Things. Okay? And of course, the networks. So this is the 4 waves of industrial revolution. So now, what is sensors and actuators? Okay? What is this in the IoT? So when you say sensor, it is a component that detects a specific physical input. Temperature sensor, optical sensor, accelerometer, gyroscope. So these are sensors, okay? These are just an example. When you say actuator, this is a component or mechanism that turns energy into motion. So the moving parts of a smart object. So these are the definition of sensor and actuator. Okay, so let's see the illustration here at the screen. So when you say sensor, that is a transducer or detector. And actuator is the mover. As you can see in the illustration, when you say transducer or detector, there are times that when you say transducer, it converts the energy. Okay? So when you say sensor here, interesting, useful energy. Okay, electric data signal. And the electric data signal is used by the actuator. So useful energy. So as you can see here at that actuator, it is a switch. So let's have an example here wherein they uses the sensor and actuators. So we have a sample here, as you can see on the screen. So we have a smartphone here. We have the user. Okay. So the users are using a mobile smartphone, and then going to connect the mobile smartphone is going to connect with the internet, of course, in the cloud. The cloud store the database, and then for in the LAN manager, wherein there is of course sensors. Okay, there is a humidity control. Okay, door will lock. On the smart home server, wherein there is a processor, APIs and actuators. Okay, so the actuators will what? Will process if they're going to check what? Humidity. And then after that, they can lock the door. Okay. So that is the purpose of actuators. Okay. This is just an example of a smart home environment. So another example. Okay. This is another example of the usage of a sensor and actuator. So we have the users here that interacts with the application. Maybe they can use a mobile application, okay? Wherein the mobile application access the data from the cloud, okay? And then after that, of course, the users starts with the sensors, with the smart switch, and then they're going to check the data. The sensor will check the data through the IoT gateway. Okay. So the IoT gateway, which consists of the WLAN and the transceiver, and the control data will pass into the actuator or the smart bulb. Okay. So this is an example of the sensor and actuator. Okay. So how the internet works? So the internet is one of those things, those things we use every day and rarely understand. So light, radio, language, our minds. In the interest of better understanding, let's try to strip a little of the mystery from this great web if we can. Okay, so language. Everything the internet depends on computers being able to communicate with each other. For that, they need a common language or protocol suite. The internet protocol, okay, is also known as what? As the TCP IP. Okay, now what is IP? The IP, the Internet Protocols is a set of rules. A part of the protocol specifies where on the envelope the delivery address needs to be written. So if the delivery address is written in the wrong place, the letter cannot be delivered. So you have to specify the right IP. Okay? Next, the Internet Protocol are set of rules governing communication within and between computers on a network. So these are the definitions of Internet Protocol. So again, IP is the protocol that computers use to talk to each other. So each device that is connected to the internet has a unique IP address that can be used for identification, just like every house in a city that has an address. So for example, for you students, your USN is a unique number that identifies you as the student of this institution. It's the same with the IP. It's a unique IP address that is used, okay, to identify this computer. Okay. So there are times that, for example, you're using different computers, okay, and then you want to pass a file or share a file or a folder into the other computer. You can do that by means of connecting to the or passing it into the IP address of the computer. Okay? So that is the usage of the IP. Now, the first major version of the IP is the IPv4 as shown here on the screen. Okay? So this is the dominant protocol of the internet, and then its successor is the IPv6, which has reached almost 20% of the internet traffic. Okay? So again, every single computer has a unique IP address. So IP address is a unique set of digits that is used to identify devices that are connected to a network. So IPv4, so 172.16.254.1 is the most widely used IP version in the world. So fourth decimal from 0 to 255, numbers separated by dots. So this is 32 bits with 4 billion combinations. So this is IPv4. So what internet protocol do we use today? So again, there are two versions that exist. We have the IPv4, we have the IPv6. So normally, the IP address are made up of binary values and drive the routing of all data over the internet. So again, the IPv4 are 32 bits long and the IPv6 are 128 bits long. So IPv4 contains 4.4 billion IP addresses. So the current estimate that there are about 100 million hosts and more than 350 million users actively on the internet. Okay? So now we have the IPv6 or the Internet Protocol version 6, which is 128 bits, okay? 8 groups of 4 hexadecimal digits separated by colons. So this is IPv6. Remember this class. And hexadecimal digits from 0 to 9, A to F, okay, which allows the address as 340 trillion, okay? 17.81% of Google users as of July 21, 2017, and 0.31% in the Philippines. So our percentage of usage of IPv6 here in the Philippines is quite low, as you can see here on the screen. So just to show the difference of the IPv4 and the IPv6, okay? Again, IPv4 is 32 bits while the IPv6 is 128 bits, okay? So this is the comparison, okay? So since these two are different protocols, they cannot communicate with each other. So for example, you have two computers, okay? You have two desktop computers and you want those two computers to communicate. You want to share a folder in computer B from computer A. So in able to do that, make sure that you are using the same IP. You're using the same version of IP. If you're going to use the IPv4, use the IPv4. If you're going to use the IPv6, then use the IPv6. But you cannot use IPv4 in computer A, and then you cannot use IPv6 in computer B. They cannot communicate with each other since they are different protocols and they are not compatible. Okay, so remember that class. So now, let's talk about what are these smart home protocols. Okay, so as you can see on the screen, we have the Wi-Fi, we have the Bluetooth technology, we have the Zigbee, and we have the Z-Wave. Okay, so let's discuss one by one these smart home protocols. Okay, So wireless or the Wi-Fi, okay? So this is one of the most common wireless technologies used to connect devices such as laptops or tablets, even the smartphones to internet routers. So you have the modem, and this, for example, you have a computer that is Wi-Fi ready. You can connect that, okay? Even the laptops, you can connect that using the Wi-Fi. So, by the way, what is Wi-Fi, class? So Wi-Fi is short term for wireless fidelity. Okay, so Wi-Fi means wireless fidelity. So a Wi-Fi network, so with a wireless connection, each student can have their own laptop, which in turn they can use throughout the entire school. So additionally, since wireless means without wires, so less cost for the cables or installation. So lastly, computers are not the only devices that can make use of the wireless network. Okay, if you have printers that are Wi-Fi ready, scanners that are Wi-Fi ready, smartphones, tablets, so all of those things can connect in the internet through a wireless connection. So the advantages of a Wi-Fi network is, of course, mobility, saves money, more devices. Okay, mobility, you can bring your devices everywhere as long as within the certain location, you can use the Wi-Fi. Saves money because you don't have to use cables and installation. More devices, not only your desktop computer, you can connect your what? You can connect your laptop, you can connect your desktop, okay, you can connect your smart devices or tablets in a Wi-Fi. Okay, so those are the advantages of a Wi-Fi network. So let's talk about the disadvantage of a Wi-Fi. So there are two categories, the security and the bandwidth. So security, it uses encryption, install firewalls, install antivirus programs. While in the bandwidth, slow speed at a public area, so campuses and cafe. So why slow? So there are times that there are a lot of users. So since there's a lot of user of the Wi-Fi in a public area, the bandwidth is divided into those users. Okay? Set up Wi-Fi connection away from electromagnetic radiating devices like the microwaves. Okay? Because that might harm your Wi-Fi. So next is what? Let's talk about the second one. We're talking about the Bluetooth technology. So the Bluetooth technology is ideal for exchanging information over short distances. Okay, so short distance, remember that. Commonly used to connect peripheral devices used to connect the wearables. So this is how a Bluetooth technology works. Emitting and receiving Bluetooth signals with a changing secret plus link to public key. So you have to provide a public key. So, so this is the Bluetooth. Okay, these are the devices that can connect into your Bluetooth. Okay, from your desktop, from your laptop, from your mobile phones. Okay, you can connect your headset. Okay, you can connect your earphones, your another mobile phone, your car, your printer, okay? And then from here, you can also connect if you have a smart device that can connect the pulse rate, the ECG, the keyboard, the mouse, okay? As long as Bluetooth enabled, can connect, okay? So let's talk about the advantages and disadvantages of using a Bluetooth. So advantages, it is widely used. It is free of charge. And of course, it is wireless. You are in control if you're going to use the Bluetooth, when you're going to turn it on or turn it off. And simple. Okay, so those are the advantages of the Bluetooth. What about the disadvantages? Battery consumption. If you're going to turn on your Bluetooth, of course, it consumes the battery of your phone. Okay, especially that if you're going to send a file. Okay, and then aside from that is low connectivity, especially if the device is quite far into the other device. Okay, next is security and the data transfer rate. It might be slow. Okay, so that is the advantage and disadvantage of Bluetooth technology. So next, we're going to talk about the next technology, which is the Zigbee. Okay, that's their logo at the left side of your screen. So this is designed for machine-to-machine or M2M communication. This is inexpensive and does not require a lot of power to operate. According to the Zigbee Alliance, Zigbee allows devices to last for years on a single battery. Imagine that. You're just going to use a single battery that can last for a year. Okay? So what is Zigbee? Zigbee is a new wireless technology. So a technological standard created for control and sensor networks. It is based on the IEEE 802.15.4 standard. It is created by the Zigbee Alliance. Okay? So Philips, Motorola, Intel, HP, or the Hewlett Packard are all members of the alliance. So now what is Zigbee technology? This is cost-effective, standards-based wireless networking solution developed for and targets applications that need low to moderate data rates and low duty cycles, low average power consumption, or long battery life, security and reliability, flexible and dynamic network topologies, so star, cluster tree, and mesh network. So those are the accepted topologies. Okay? Interoperable application frameworks controlled by an industry alliance to ensure the interoperability or compatibility. So these are the applications of the Zigbee technology. So Zigbee wireless control that simply works. It could be the building automation, lighting control, access control, or the securities. It can also control the personal health care, like the patient monitoring, fitness monitoring, okay? And then it can also control industrial control, asset management, process control, environmental, energy management. It can also control consumer electronics, okay? So those are the applications of Zigbee, TV, VCR, DVD, CD, or remote. It can also control PC and peripherals, mouse, keyboard, joysticks. It can also control residentials or light commercial control, security, HVAC, lighting control, access control, lawn and garden irrigation. So that are the applications of the Zigbee. Okay, these are the example of how does the Zigbee works internally. As you can see on the screen, okay, example that the computer or the TV or the PC or the webcam, okay, or the gaming console or the audio uses the IPv4 with the use of the smart Wi-Fi Zigbee router or gateway. Okay, the Zigbee can control the in-home energy display, the smart water, smart gas, smart heat, smart electric, solar panels, sensors, security, light, and appliances. Okay, with the use of these smart Wi-Fi or Zigbee router through the use of the mobile device, okay, here as shown on the screen, it will connect in the IP network to check and of course the service provider. Okay? So the last one is the Z-Wave technology. So when you say Z-Wave technology, this is primarily designed for home automation. So according to the Z-Wave Alliance, the Z-Wave protocol is an interoperable wireless or RF or radio frequency based communication technology that is designed specifically for control, monitoring, and status reading applications in residential and light commercial environments. Okay, so that's the use of the Z-Wave. So for the home control, so the Z-Wave can what? Do energy conservation, can control home entertainment, okay, home control, remote home management and monitoring, safety and security, comfort and convenience, okay? That are the accessible devices for the Z-Wave. Now let's try to compare the variables, the four different variables or the four different smart protocols, okay, or the smart technologies here. So as discussed a while ago, we have the Wi-Fi, we have the Z-Wave, we have the Zigbee, and we have the Bluetooth technology. So we have variables here to discuss. So year first launch in the market. So Wi-Fi was launched year 1997. The Z-Wave was launched 2003 in the market. Okay. Same with the Zigbee. Zigbee was launched in the market last 2003 and the Bluetooth technology was launched in 2010. If you remember, before we have the Bluetooth, we have the what? Infrared, right? And then we have the MAC standards here, or the physical address, IEEE 802.11-1. The Z-Wave uses the ITU-T G.9959, okay? And the Zigbee uses the IEEE 802.15.4. The Bluetooth technology uses the IEEE 802.15-1. While the frequency band for the Wi-Fi is 2.4 gigahertz, so Z-Wave uses 900 megahertz, the Zigbee uses the 2.4 gigahertz, and the Bluetooth technology uses 2.4 gigahertz. Okay, so that's how you can see on the screen which is better. Okay, try to analyze what is much better for these technologies, and of course what is the most applicable for you. And then we have the nominal range. So we have 100 M here, 30 to 100, 10 to 100, and 30. Maximum data rate. We have the 54 megabits here on the Wi-Fi. We have 40 to 100 for the Z-Wave. We have 250 for the Zigbee, and we have 1 for the BLE. So the topology used for Wi-Fi is star. For the Z-Wave, it is mesh. For the Zigbee, it is also mesh. And then for the Bluetooth, it is scatter net. So power usage for the Wi-Fi is high. The Z-Wave, the Zigbee, and the Bluetooth is low. So alliance. So the alliance for the Wi-Fi is Wi-Fi Alliance. The alliance for the Z-Wave is Z-Wave Alliance. And then the Zigbee is Zigbee Alliance. And the Bluetooth is the Bluetooth for Zigbee. So that is the summary of the four different smart technologies.